So today we talk about inheritance. So the took lecture material relevant to an example we're going to do together, and then we're going to do an example that illustrates how you inherit classes. And then I think we're going to run out of time. We have lack because you need your lag time. And then on Wednesday we're going to finish the chapter and talk about abstract classes. All right, so here is a business class product maintenance application. And so this is an example where why would you want to use inheritance? If you have a product class, you have two different types of products, the book and the software. They're both products, but they're different from each other. However, they both conform to a certain structure that is can be expressed as a product. So what we can say is your book and your software class can inherit from the product class, and then they can extend the functionality, the book having, for example, an author, and the software having, let's say, a version number. So this is how you might use inheritance. The product is considered the superclass, and these are the subclasses. So if you inherit from a class in Java, this means that you can use the super as you need to, as they are rather, or you can also what we call override them, and you can customize them further in your subclass. So these are two different ways in which you can extend and reuse the functionality of your superclass. Java is what we call a single inheritance, meaning that a subclass can only inherit from one superclass. So you can't have a book inherit from product and, I don't know, employee or something else. So it can only be a single inheritance line, which is actually a good thing because it makes troubleshooting easier. Java provides another structure called interfaces that allows you to essentially simulate multiple inheritance. Right? Okay. Oh, and in addition, as I mentioned, you can reuse these classes or these methods or override them, and then you can write your own methods that are only present in the subclass. Excuse me. So the superclass of all classes in Java is the object class, and these are some of the methods that are available to us from the object class. This means that every class in Java inherits from the object class. For example, the toString method is a method that is going to return a hash value representing the object, but it is a standard practice. If you need to print something in a subclass, you're going to override toString and then use this method rather than writing your own. So there's just a practice that we see. So this is, for example, the hash code. You just call string method directly. So here is a list of access modifiers. We have been using private, so the private will be available only in the current class. The public is available to all packages. There is another access modifier called protected, which we haven't used yet, I don't think. And the protected is available to the same package that you're in, and then to any subclasses that you inherit from the superclass. If you don't specify a keyword coded, so the default behavior is the same as the same package. If you want to override, or you can customize a method from a superclass, you use the @override notation, and then you write your code here. So this is new material, I think. So here's an example where the product has a protected count. So this is only available to this class, to this package and the subclasses. And then this is an example in a product class how you might override the toString method, and you override it by returning, for example, the description from the product rather than the hash code when you print.
The protected, that wouldn't really be applicable unless we have several packages inside of a workspace, right?
Well, it would be applicable if you're planning to do inheritance, even if it's in the same package. if you want your subclasses to see it, you can also define them as protected. Right. So two different cases when you might want to use it. All right. Let's see. Okay, so how you work with subclasses? The keyword, if you want to inherit from a superclass, is extends. So you're going to say, the class name extends the superclass. So the book class is going to extend the inheriting classes you want to create. You want to call the constructor of the superclass so you can instantiate it as well. And you do this by calling the super keyword. So the super, and then any argument list will call the constructor of the superclass. And you can also use it by saying super dot method names of the superclass. So that's another new keyword that is just becoming known to you right now. Here's the example with a product. So we have a product class that is extended by the book class. And so in the constructor of the book, you're going to call the super, which is going to instantiate the product, as well as whatever else you're doing in the book constructor. Here.
So when you call use that constructor super inside the book, it brings in all the methods from that.
It doesn't bring the methods, but it's going to essentially instantiate the
so
product.
that you can use all those.
And then you can call super dot
Okay.
the name of the method. So
Right.
it has two different uses. As for example here.
Okay.
So this is calling the super of the product because the toString was implemented in the product. So when we call super dot toString, it's going to pick it up from product. And so you can see that you might have different versions of the toString method. We're going to do this example hand-coded together. So I'm skipping over the slides. See if there's anything else to add. Well, okay, so this is an introduction of what inheritance is about. And again, it enables you to use functionality from a more generic class in a subclass, and then extend this functionality and customize it as needed. Maybe we can think of some, before we do our example, could you give me a couple examples from real life where it might be appropriate to use inheritance? Let's think of a few examples. Anyone? I have to go grab a paper tissue. I'm hearing it right now, so I'll be right back. You think about my question, and when I get back, you better have something ready for me. Okay.
You won't.
She was trying to bring me in my face food. You give me an 8+ on my face food? I'm gonna be ready in real life. See nothing.
I can see what I did over there.
Okay, so examples, please. Alec,
Music store.
all right,
Like you could do subgenres.
all right, absolutely. Well, yeah. So what would be the superclass and what would be the subclasses in your example?
Could be like. Could be maybe like songs, or like not songs, but like records of like just like records together, and then you could go what kind of format. So like digital,
Okay, that's a good one. Alright.
vinyl,
Okay,
MP3.
I like that. So we have a superclass records, and then you have different types of records that have some slightly different characteristics that you can represent. That's a good one. Karen.
Cars.
All right, absolutely. That's
Yeah.
a classic one.
Yeah, I mean, but-
Yeah.
Or cats.
Okay, so here's the breakdown of superclasses and subclasses for those two.
You have, I guess your superclass would be like, everything about that all cats have, like fur, number of feet, whiskers, ears, and then your subclasses, you can have the different breeds.
Okay, yeah, because they're slightly different.
Yeah, I mean, you could have like, yeah. You could have like, some breeds are long hair, some are short hair,
Right.
some are medium. Whereas,
Couldn't you just have a class cats with a breed property? List is variable. I'm just really
Yeah.
thinking out loud.
Yeah.
But with cars, so I guess with cats, I'm not sure that you need to have subclasses for birds. You could, like you're designing it, but I don't know if that's necessary. Now, the classic example would be, mammals, and then
Scientific classes.
the scientific classes. Yeah, exactly.
So it has to be different.
Genus
It has
and
to be different
animals.
things.
Yeah,
Was that Michael?
they're saying there's like, has to be like different methods to kind of,
Well, they have to be different enough to be worthwhile to create a subclass. So tell us the example with a car, Kieran.
I guess the way I would describe it with a car would be, you have different cars have different options. Or,
like truck, van.
Instead of
Yeah,
just car,
motorcycle.
automobile.
I would say
It's
vehicle.
oh yeah,
How
vehicle,
about
and then
vehicle?
it breaks down into cars,
Yeah.
trucks, motorcycles.
Yeah, exactly. Right. Because these are different enough, so you can describe, they're all vehicles, but a motorcycle is sufficiently different with two wheels and all that. Okay, Sophia?
I don't know, I'm thinking about for example, superheroes, for example.
Superheroes.
Yeah, imagine he's super strong, and there's a guy, he gets all his powers, but he got his own power at the same time. So it's kind of
Right.
the same, he got all the functionalities from that guy, but he got his own at the same time.
I think that's absolutely
Yeah.
a good example as well. Yeah. So I don't know much about superheroes, but yeah. So all superheroes have a superpower, and then the
Yeah, just
Iron Man does whatever. Okay, like Luke Cage is the only one I know. Anyway, all right. So that's another good example. And Michael, you had a comment? No. Okay. Well, give us one more example. Give us something with clothing, or anything else. It doesn't have to be clothing.
Clothing, you use like clothing,
Okay.
so there's like tops, bottoms.
I think that might work just fine, right? So if you have what is the word clothing or garments on? Okay. And then you have different categories.
Socks.
Right. Exactly, because
Like
socks are quite
outfit,
different. Outfit maybe is the
and
word.
then
Or,
different, you can mix and match different outfits, like you don't need all the parts for one.
okay.
So you don't need socks for one.
Right. But all outfits have size, I guess material and maybe origin of material, and then socks have a different. Everybody's laughing. I guess that example can go very funny. I agree. All right. So you can play with this one. Anything else? Zach, come out with the motorcycles. Anything
Yeah, I would
else?
say there's motorcycles by the manufacturer and the different models that every one category. Honda makes 6 different categories of motorcycles in each model. And same with manufacturer.
That's again, I'm wondering the same as with the cat, if those characteristics are different enough that you should make it into a subclass, or if you can present it in the same class as properties. So this is one question you should ask yourself when you're designing your own classes, right?
Maybe it could be
So
about
like with motorcycles, you'd have like street bikes and
Yeah.
off-road.
Right.
Because they're sufficiently different that,
Are they sufficiently different?
Oh,
Yeah,
it's
so
like
okay.
SUV, truck, car.
Right.
They're very different. stuff.
Okay, so then that's a
Yeah,
good
you-
one.
how about iPhones?
Phone? iPhones or phones?
Yes, like smartphones, like they
Smartphones, yeah.
like the example of iPhone, every time they get all the functionalities, but they are some.
Right.
It's kind of amazing.
Well, that's a good one. Yeah. I didn't think about it like that. My son was just showing me the iPhone 8. I guess it doesn't have anything on the side, it's only a screen. I don't use iPhone, but
no.
he does. So, yeah, so we can think about it like that. I think it's very applicable to the real world, so I like to think about it, and it forces you to structure up front, which is something else I like. So all this said, let's go ahead and do an example together with a product, and then the product is going to be extended by the book and the software. And then let's see how this gets coded and how it gets instantiated and called from the main. So please start your Eclipse. Right, here we go. So close this solution here, or that's something else? That's something else. All right. One moment. I think usually we don't get to inheritance in the first programming class. Has anyone covered inheritance prior to this class? In which class was that?
Oh, no, not here.
But otherwise,
Yeah.
right? Which language?
Java.
Also in Java?
Yeah.
Just 1 second, sorry. So we do need to start a new project. Everything is very sluggish at the moment. Is it the... Is anyone having troubles with Eclipse becoming very sluggish from time to time?
Especially when we're relaxed.
What is that about, do you think?
I wish they would have them all at the same version.
That would help. But
Yeah,
have
they're
a,
super slow with all the other labs. It takes like 2, 3, 4 minutes to start up.
yeah, it's unacceptable.
I don't know what version I use.
For Neon,
You're not using the That's new.
the Neon is the new one. Which one are you using?
Seems like Halos.
That's an older one.
Yeah, I don't know that.
And
For
everyone-
Mac.
All the one over here are all Luna.
They're all new one. That's a pretty old one, as I recall.
Yeah.
All right. Okay, let me magnify this. So we start a new project. Let's call it Chapter 11 product, underscore product. Pull these out. All right, and then we're going to have 3 packages. So add your packages. Package 1 is the business, or let's see, business. DB. And UI. All right, so in the DB package, go ahead and right click. We'll start from here and say new class and name it product DB. And I don't think we need to code by hand. The product DB is the same as we've done before with the conditional if then else. So I have uploaded it to Week I guess 7. So please go to week 7 on Canvas, and there is a product DB Google Doc.
Is it 11? Is it 7 or 8?
It's in 7 because we were going to start on this last time. So go to week 7, please. And then open the product DB, edit, select all, copy, and then you're going to delete here what is in this. Yes, and then paste. And I didn't add Murak, so we're going to remove the Murak from the package names. So you just replace it. And it's going to complain about not finding certain classes and methods because we have not coded them yet, so that's okay. And then just save it. And as a refresher, we just look at it instead of coding it. It's going to set product codes, description, and price based on the product code is going to set the product code, the description, and the price for each of the products, right? The class name is product, capital case D, capital case B, product DB for database.
I have that.
Product D.
Are we good with copying and pasting?
After I paste into my file, do I need to change something?
The only thing you need to change was that I didn't add Murak to the package names.
Oh,
So if you had Murak dot, just take this out. This example is from the book. All right. So let's code the product class next. And this is going to be the business package. And again, it's to have errors right now because the product DB is referencing classes we haven't coded yet. So we're going to fix this momentarily. All right, go in the business package, please. Right click and create a new class, product. A new class, book. They don't have name. And a new class, software. And just to point out, this is also extendable, meaning that, let's say, if you're a business and you start with 2 products, as you can see, you might have additional products and you can still inherit from the product class. So it's an extensible model. All right, back to product, please. So we have the instance variables. We have a private string code, private string description, private double price, and a protected static int count, which is equal to 0. All right, and then the constructor, which matches the name of the product. Oh, okay. This needs to be. I don't know why I wrote software here. This is a product class. So if you made this mistake with me, please fix it. All right, what is going on? Oh, I'm in the software. Okay, so this needs to go in the product. For some reason, I'm writing in the software and I need to be in the product. Okay. Right. Then let's go ahead and add the getter and setter methods, and we can do this with the help of Eclipse. So right click, source, generate getters and setters for all. And there they are.
Where did you put the getters and setters?
Where do you click it to start?
Yeah, how did you?
You right click in the white space and then go to source. And so go to source and then generate getters and setters down here. Okay, so after the getters and setters, we're going to add a couple custom methods. We're going to have a public returning a string, get price formatted, so number format, currency, get currency instance, return currency dot format price. Okay, and then we're going to use the @override annotation, and if you hover over it, well, I guess we first have to put the method and then we can look at the documentation. Write @override and then we're going to override the public string to string. And so this is the toString. We are overriding the toString method of the object class, which is again the root of all Java classes. And then instead of returning a hash code representing the object, we're going to return description. And again, why are we doing it like this? We don't have to. It's a convention to use the toString method, so that's why we're doing it. And if you hover over override, take a moment, please, and read over what Eclipse tells you about it. So it's indicates that the method declaration is intended to override the method declaration in a subtype. If a method is annotated with this annotation, type compilers are required to generate an error message unless at least one of the following conditions holds. The method does override or implement a method declared on a super type, or the method has a signature that is override equivalent to that of any public method declared in object. Okay. Do you have any questions on lines 53 through 56? No? Great. All right, and then last method is going to be a public static returns an int, get count. It's going to return count. Oh, we already have the count from the, so sorry, delete that. The get count was generated by the getters and setters. Any questions on the product class and what's going on in here? Right. Yeah.
Why is static count?
Why is it static?
Why have it static? Yeah. Why
You don't
Yeah,
have to, so with static, you don't have to have it static. It's just a method if you want to call it on the
Yeah.
class, right?
Well, I guess this isn't your. This is in the book, so I guess I don't know. Reason
Well-
why using static count instead
Just a regular.
of having it somewhere else. Instead of keeping, I'm assuming that's
Well, I think it should be in the product. I mean,
instead of I'm assuming that's the number of products.
well, it's going to be a number of products, and it will polymorphically be used from the book and the software. So I think this is a good place for it. And it's static because it's going to be called from the other classes, and you can call it under the class directly. You can certainly declare it non-static. So, so the count will be, I'll talk about polymorphism in a little bit, but it's going to be able to count any type of product. So, okay, we have to declare it in the product class. And I guess I didn't answer your question, but I don't know what else to add. All right, so then let's work on the book class. All right, so the book class is going to inherit from the product class, and so we're going to use the extends keyword to call this in Java. So it's extends product. And then the product is going to have its own instance variable author, and we would like to then create a constructor for the book in which we're going to call the super, which is going to be calling the constructor of the product. So that's how we construct the superclass instance. And then we have author equals to an empty string and count plus plus. So we're incrementing the count. All right, and inside the class, if you right click and go to source, and then select the author, and then generate getter and setter for this class, for this instance variable rather. And here we're going to override the public toString, public string toString with the following. So here's what we're going to do. We're going to call super.toString. So is this calling on the object or on the product? When I say super.toString here, which one do you think it's calling on?
The public book is super.
The product is super. It's a super product. So in this case, when we say super.toString, this is going to return the product implementation of toString, and then we're going to add to it the author. So again, it's helpful, I think, to think in terms of the subclasses customize the superclasses, right? So you're using and then customizing. You don't have to do certain work from scratch because you just inherited to use it from the superclass. Questions on the book? So there are a few inheritance things going on here. So we're inheriting from the product. We are instantiating the product by calling the super the super inside the constructor of the current class. So count is static, so we can just say count plus plus here on the incrementing the count. And the reason we want to increment the count here is because if a book is created or is instantiated, it's a kind of product and we want to keep track of those books, right, and increase the count. And the other thing we did here was we're overriding toString and then we're returning super.toString. So that's the super method of the, so that's the toString method of the product class, and then we customize it further with the author. Okay? Questions? Does it make sense now? You okay so far? All right. So let's add the software. So you have a public class here. Public class software, you should already have that. And it's going to extend which class? What are we going to extend? Product. And so software is different from, let's say, from a book because it has a version. So we are going to add an instance variable version. And then the same thing, we call the super. Instantiate the version. And increment the count. So I don't know if this is clear, but essentially every time we instantiate an object, we're going to be incrementing the count, right? So we have yet another product created, yet another book, yet another software, right? Does this make sense? So remember, when you instantiate, you have one object, but you can have many objects from the same class. And every time you instantiate it, you can keep track of it via the count. All right, let's use the getter and setter to add getter and setter for the version. So source, getters and setters. And then we're going to override the string. But in this case, our product information is the same, but we have a version instead of, okay.
You reuse chapter.
Yeah, something is off. Let's see. There you go. You're right. Thank you. And then to string is to have ranks. So I'll let you finish that. Let's see, it's not liking the,
Space between the count and the flush plus. That's the problem. Give her that space.
no, it shouldn't matter, it's a white space. Let's see, let's see here. Cannot resolve to a variable. Really?
Try products.com. See what happens.
Maybe you need to just save. Let me just save all real quick. You didn't have. Save all. Okay, it wasn't saved. Reboot or
That's
save?
Another reason just to save often.
Yeah,
really not.
exactly. Just save often. That's a very good advice. All right, so then let's create our main method and call this and see how it works. Maybe we can finish it before break. All right. So go in the UI folder. And then, sorry, the UI, and then a new class, product app. And I forgot to create the main, so yeah, so the main always goes in the UI package because it's our user interface.
We have three packages.
We should have three packages. So I can magnify here, Michael, if you take a look, and anyone else. We have business, DB, and UI. Okay, and I forgot to add the public static void main. Okay, and so we display welcome message. Welcome to product viewer app. Space. And then let's do a perform selection. We have a new scanner. string choice. So while the choice is equal to yes, enter product code. And then string product code will be equal to the next line of the scanner. Then let's get the product object. So I'm going to ask you to explain what's happening here. So this is the following lines: product P, so product DB dot get product of product code. I want to, let's see. So probably need to include why is it not liking the product here? Let's see. Was that?
Just save.
Yeah, I did.
Okay.
I can't save anymore. I know. I tried saving. It's not allowing me to save again. So it's saved. Okay. Are we not including a package, or what is this here? Package line.
Does it error say?
It says product cannot be resolved to a type.
Oh, so it can't resolve the product type.
Yeah.
So you import.
I guess you're thinking if we import business.product. Oops. Yep. Okay, so it asks us to import the class, the package, and the class containing the product. So if you're having this error, import the product. Yeah, because that makes sense. Okay.
There's also an option that requests to auto import whenever you save.
Okay.
But
I like to know what's going on.
yeah, it'd be good to.
Yeah, exactly. Okay, and then we display input. So we're still in. Oh wait, we didn't talk because we had an error here. Who is going to explain to the rest of the class what is going on line 25? And you may need to reference the product DB class to be able to answer the question. Got it?
Folding up everything in the database.
Just loading. This is the
Loading.
loading everything from the database into the app class. Okay. And why is this returning a product? Because that's what we're returning from that method, right? So the method from the product DB class get product returns a product. And this is why we are doing this. And it's inside the get product is condition, so it's going to there's the type of product out here. Because in the product DB we have those now statements that are going to say different based on the product code, right? All right. Okay, so then display not the input but the output. System out print line. Put space there. And so if P does not equal null, so if no product was, then the return type for the object would be null. So we're saying if there is object, then we're going to print the description of the product. So P dot toString and price get price formatted. Else we're going to say system out print line, no product matches the product code. System print line for space, and then we're going to print the product count. So because it's a static, we can say product dot get count. And then continue, yes or no. So this is in the while loop. Then close the scanner. So enter protocol Java. MySQL. And then give it a try. Looks like, see here, description. So I need to add a space after by here in the book. The words are bunched up together. But otherwise, did you try this? Is it working for you? So you have a Java. Okay, let me magnify. Okay, so I said protocol Java. It tells us the And the author name, we didn't save. It's Java description, product count 1, another one, MySQL, product count 2, and this is what the class and the app should do. So maybe we can take a break, and then when we come back from break, you can ask any questions you have, and we can have open lab after that. I think there may be a couple other points I'd like to make here about how this works. Are there any syntax issues for us to look at right now? Syntax?
I have a, my own,
You say what? Yeah, so
awesome, thanks.
yeah, sorry about that.
That's great.
I should have put it there. All right, let's do our first break. Another break.
recording is correct.